Hello, welcome to my channel. Maya, and we are discussing problems on root locus. So today again we are going to solve one more problem on root locus with graph. So let's see. We have a problem g of s, h of s is given to be k into s plus 4, s plus 5, and s plus 3 and s plus 1. Okay, so there is a numerator, there is a denominator, and first step we need to find is number of poles and zeros. So poles are the values for which my denominator becomes 0, so I will just take p is equal to 2 and values for s will be -1 and -3. Okay, and I will take z is equal to again 2, p and z. So numerator values, that is -4 and -5. Okay, so for this you can calculate number of branches. Number of branches will be p or z, whichever is greater. In this case p is equal to z, which is equal to 2. So number of branches will be equal to 2. Number of asymptotes will be equal to p minus z. In this case 2 minus 2. So there is no asymptote, and this is something different. For a root locus problem, there is no asymptote in this case. Okay, and that gives you the special case. So there is no asymptote. So let us try to understand how the root locus will look like first, and then we will try to solve further. Okay, so I'm just trying to axis again with horizontal and vertical axis. So let us take an example. This is origin. So I'm just making a double scale because my scale is not moving more than -5 on real axis. So if you have 10 divisions on left hand side, you can easily double your scale. So I'm just doubling the scale so that it will be very easy to plot on a larger scale. So -1, and I will double the y scale also. It is better to have a same scale on both the axes. This will be positive, not negative. Okay, so the first step is marking your poles and zeros. So we will mark poles with X and mark zeros with a hollow circle. Okay, so first poles, let's mark poles, that is -1 and -3. So at -1 I will do the marking, at -3 I will do the marking, and zeros are at -4 and -5. So at -4 I will have a circle, and at -5 I will have a circle. Okay, and next thing is root locus on real axis. The rule is simple: if there are odd number of poles on the right hand side of each pole, there will be a root locus. So let us start with the first pole. There is no root locus on the right hand side, so there will not be any root locus. Let us move to this next pole, or 0. There is one pole on the right hand side of this -3, so that is an odd number. So if that number is odd, there will be root locus. So there will be root locus between -1 and -3. So I am just highlighting it for your reference. Whenever you are trying to solve it, just make a dark line with a pencil. Okay, so there will be a root locus between -1 and -3. For -4 there is a 0, so count the number of poles and zeros on the right hand side, that is -3 and -1, that is 2. Count is 2, which is an even number, so there will not be any root locus on this side. Same thing goes for -5, -4, -3 and -1. So that's odd number, 3 poles and zeros on the right hand side. So there will be root locus between -4 and -5. You take one more pole, you assume one more pole on this side, -5, -4, -3, -1. That is 4 poles and zeros, which is an even number, so there will not be any root locus on this side. Now about the branches, root locus branches will always start with pole values and it will end either at 0 or infinity. So in this case, these two are poles. So one branch will start at -1, go towards -3. One branch will start at 3, go towards -2, because both are poles. So what will happen is these both branches will come at one point, they will take away and go towards the infinity or 0. And in this case there are zeros which are available, so that's why those will be ending points of the branches. So what do we understand from this is there is no asymptote in my system, so my root locus is not following any asymptote, and there are two zeros in my system and two poles. So there is one branch which is starting at this pole and ending at this 0, and there is one branch ending at other 0. So my end points are fixed, my start points are fixed. The only thing is how they are going to travel from this to this. That is what we need to find, and that can be determined by the breakaway point equation for breakaway point. And what do we do for breakaway point? We basically take 1 plus g of s h of s is equal to 0. We rearrange it to form in terms of k. So what do we have here is minus s plus 3 s plus 1 upon s plus 4 and s plus 5, and then we take dk by ds is equal to 0, equate it with 0 and find the values of s. That will give you the intersection with imaginary axis, sorry, intersection with the real axis. So again this is u upon v rule, both the terms are having its values of s, so we will be using uv rule for derivative, and the final value which you get will be, after solving whole uv rule, you will get minus 5s square minus 34s minus 53 is equal to 0, and you equate it with 0, you will get the values of s to be minus 4.379 and minus 2.420. Okay, now we have to check whether these values are lying on my root locus or not. So we will go to the graph. First value is 2.47, 2.4 is 2.42, so that is 2.4 somewhere here, which is on my root locus on real axis, and one value is minus 4.3, which is again on my root locus. So what we understood from this is this 2.4 is lying between -1 and -3, that is basically breakaway point. Breakaway point. And the second point is lying between -4 and -5, that is also on root locus, and that is basically break in point. Okay, so one is break away point and one is break in point, so we will just mark those things, that is break away point and break in point. And what basically will happen is both root locus will break away from this point, one will go in up direction, one will go in down direction, and they will break in again at this point, which is 4.3, and one will go towards 1 0 and one will go towards other 0. So there is no intersection with imaginary axis, so this will be mostly last step, no intersection with imaginary axis. So you don't have to go for a further step for solving the Rao's criteria and find the intersection, because from graph we understood that there is nothing on right hand side, there is only root locus in this area. Okay, now how to draw that? What basically you want to do is you want to calculate the distance between this 4.3 and 2.4, which is somewhere around 3.8. Okay, so or 3.7, 369, 3.9, so that will be around 3.9. So what you have to do is you have to draw a circle with the diameter of 3.9. And why circle? The ideal shape for root locus is a circle. So whenever you don't want to give a smooth curve for root locus, you always tend to draw a circular shapes. So it will look something like this. If you have a rounder, you can just draw a circle with rounder. The direction is very important. Direction will be going towards the zeros. So one root locus will start at this -3, go on upside, break in into the point, and then go to 0. One will start from -1, go on downside, and then it will go towards the other 0. Okay, you have to mention break away point, which is -2.42, and you also have to mention break in point, which is 4.3, -4.379. Okay, so this is one of the special cases of root locus in which there is no asymptote and there is no intersection with imaginary axis. So root locus will tend to have a circle, ideal shape, which is a circle, and this is how you basically draw the special cases of root locus. Two poles and two zeros, that will give you no asymptotes. Number of branches will be 2 and there will not be any asymptote. So this is how you solve these special cases of root locus on graph. Okay, so if you like this content, do subscribe my channel, hit a like button, share it with your friends, and keep following for more videos on control systems. Thank you for joining.